Here is another question on application of primary trigonometric ratios. Question 21. Ellison is flying a kite and has let out the entire 150-meter ball of kite string. She notices that the string forms a 70 degrees angle with the ground. Mark is on the other side of the kite and sights the kite at an angle of elevation of 30 degrees. How far is Mark from Ellison? So we need to find distance A to M. Now here is a figure which represents the given problem. So Ellison is flying a kite, and that is 150 meters of kite string making an angle of 70 degrees with the ground. Mark on the other side sees the kite at an angle of elevation of 30 degrees. And we need to find distance between Ellison and Mark, which is AM in this diagram. Now first let's analyze the situation. Let's say we drop a perpendicular from K and it meets this line AM at L. So this is a perpendicular. So that gives us two right triangles. Now we can solve these two using trigonometric ratios. Since we need to find AL and LM, we also need to find KL, because KL will help us to find LM, right? So let's solve these two triangles. First, let us consider the triangle AKL. So in the triangle AKL, 70 is given to us and hypotenuse is given to us. We can find opposite side and adjacent side, right? Using sine and cosine, correct, of 70 degrees. So cos of 70 degrees will give us AL, which is adjacent side, over hypotenuse. Hypotenuse is 150. So from here we can say AL is equals to 150 times cos of 70 degrees. So you'll use calculator to figure this out. So 150 times cos of 70 equals to 51.3. So we get AL as 51.3. Now we can find KL using sine, right? So sine of 70 degrees is equals to KL over 150, right? So from here we can find KL, and KL will be equals to 150 times sine of 70 degrees, which is 140.9. So let me write this as 141, correct? So we know KL is 141 and we know AL is 51.3. Now this height KL will help us solve the triangle on the right side, right? So in the right side triangle, now we need to find the horizontal distance LM, right? So we can use tan. Because opposite side is given to us, we need to find horizontal distance. So opposite and adjacent gives tan 30, right? So tan 30 degrees is equals to opposite side of 141 over adjacent LM. So from here LM is equals to 141 times tan of 30 degrees. So which is 141 times tan of 30 degrees, 81.4, right? Now what is AM? So from here we can find what AM is. So total distance between Ellison and Mark is AM, which is equals to 51.3 plus 81.4. This is 81.4 plus 81.4. That gives us 51.3 plus 81.4 is 132.7 meters, right? So approximately we can say 133 meters. So that is the distance between Ellison and Mark. I hope you appreciate how we solved both the triangles, right? So it was kind of important for us to find the height so that we could solve the next triangle, right? And in this particular solution, we used all the primary trigonometric ratios, sine theta, cosine theta, and tangent theta to solve. That's a good application for you. Thank you.